Okay, good evening, welcome to...
Remind number 867.
867, alright, so yesterday we did a project out of Richard Evan Schwartz's really cool book called Gallery of the Infinite. What was that project about?
It was about bijections.
Bijections, and you picked something you thought was interesting. What was it?
I believe it's the Cantor set.
Alright, show some of the pictures from the Cantor set.
So they have... They show it like kind of like a fractal.
Okay.
We have this picture, which is an eye, and then it goes like this,
Okay.
and then it goes like this,
Alright.
and eventually it'll just get. You take each square, you divide it into ninths, and take the middle ninth that way.
Interesting. Okay, cool. I'm going to talk about two things about a slightly different Cantor set, but also you'll see it's the same idea.
All right.
Go ahead, take it over. So a different version of the Cantor set is you take let me just grab a couple other markers. We're having marker trouble tonight. You take say the real line between 0 and 1. And what you do is you do the same sort of thing you were doing in 3 dimensions, except in 2 dimensions, except in 1 dimension, instead of taking out the middle ninth, we're going to take out the middle third.
Okay.
Okay. So why don't you mark the middle third, and then you can erase.
So we just take that away.
All right. Then the next step is taking out the middle third of what's left. Okay, and then take out the middle third of what's left. Okay, so stop here. So you can see kind of what's going on. So what do you think is going to happen? Can you tell me what you think is going to happen here
Well, eventually you might take everything away.
Eventually you might take everything away. What do you think?
So I think everything, eventually, if you do this infinitely many times, you'll get down to a point where you can't take numbers away anymore. There aren't any gaps. But there aren't any like sections of real numbers. You get down to individual real numbers.
Ooh, interesting. You think we're going to get down to individual real numbers?
So there are numbers left, but there's nothing. There's no two numbers are grouped.
Okay, interesting. What's the number that you think will be left?
Well,
every number you can think of will be taken away at some point.
well, see, these numbers, like right here, won't get taken away. 1/3 and 2/3,
Okay.
because they're right on where they're not ever going to be in the middle third.
Interesting.
And then, like the numbers here,
To the end
yeah,
points.
the end points.
And 0 and 1 too.
Okay.
These.
So the interesting thing is the endpoints of all the intervals are left. Okay.
Yep.
How many numbers do we start out with in the real line?
Well, there is infinitely many.
What
I
kind?
think uncountably.
Uncountably many.
Yep.
All right. So if we end up with these discrete points left, so what would that mean? We would end up with how many points?
Try to countably
Yeah.
infinite.
Okay, interesting. Now I'm going to show you sort of one really pretty interesting way to think about the Cantor set and this middle third removing process.
All right.
Right?